Hello friends, we met again in chapter linear motion. First, we look the objectives in learning this chapter. In this chapter, we will learn about speed, displacement, velocity. We will learn about the difference between distance and displacement. We also learn the difference between speed and velocity. Then we learn about uniformly linear motion, uniformly accelerated linear motion, free fall motion, and upward vertical motion. Okay, we begin problem number 1. A car moves 80 kilometers to the east, then turn around 30 kilometers to the west. Find the distance and displacement which travel by the car. The distance can be found by adding all of the journey, so that we add the 40 kilometer, the journey AB plus BC, the 80 kilometer plus 30, so we get the 110 kilometer. Okay, but the displacement is not same. The displacement have see the direction. If AB is to the east, it has positive value, but the B to C journey to the west have negative value, so that the displacement is only seen from initial point to final point. Initial point is A point A. Final point is point C, so that AC can be found by 80 kilometer minus 30 kilometer, and we get 50 kilometer. Okay, this is the difference between distance and displacement. Okay, next, number 2. Find the average velocity of the object which shown in graphic below. The graphic show in y-axis is distance and the x-axis is time. The unit is second. We see the initial point of the object before move at the point 40. Then the final point in this point has the position at point 100. Okay, the average velocity can be found by calculate the displacement divided by time, so that we can calculate the distance, the final point minus initial point. The final point is at 100 minus 40 initial point divided by time 40 seconds. Then we get the 60 divided by 40. Then we get this value is 1.5 meter per second. This is the average velocity. Next, number 3. This figure shows a journey from A to C through B. The distance AB 40 km, travel in half hour. Distance BC 30 km, travel in 2 hours. Find the distance from A to C, the displacement from A to C, the average speed, the average velocity. Okay, first we calculate the distance from A to C. The distance can be found by adding all of the journey in positive value, all, so that the distance AC is AB plus BC. So we get distance AC AB is 40, BC is 30, and we get this value is 70 km. Okay. The displacement from A to C. In the displacement, we have to see the initial point and the final point, and we have to draw a line from initial point to final point. So the line AC is the displacement. We see the displacement AC is hypotenuse side of triangle ABC. So that the displacement AC can be found by root of AB square times AB square plus BC square. AB is 40 plus BC is 30. So that we get the 40 square is 1600 plus 30 square is 900, and we get the value is 2500. So that we get the AC is square of AC is root of 2900 is 50 km. Okay, so we calculate the C average speed. The average speed can be found by calculate the distance divided by time, so that the speed is distance is 70 km divided by time in 2 hours, so that we get the 35 km per hour. But to find the velocity, we have divided the displacement divided by time. So we get the displacement 50 km divided by 2 hours, and we got the value of 25 km per hour. This is the difference between speed and velocity. Okay. Next, number 4. The distance from B to M is 420 km. This distance can be covered within 7 hours. Determine the time it will take the car to reach the city of B, which has a distance of 900 km from the city of B. Okay, to calculate this question, we have to find first the velocity of the first process. The first process journey from B to M is 420, so that the velocity can be found distance is equal to velocity times t. Okay, 420 equal to v times 7 hours. Then we get the velocity is 60 km per hour. Okay, we apply this value to the second process, d equal to v times t, but the distance we input the new value of 900 km equal to v is 60 times t. Then we get the value is 900 divided by 60, and we get the value is 15 hours. This answer can also be found in using another method by compare the both of process. Okay, the other method is comparison. Okay, distance 1 equal to velocity times t1. Distance 2 equal to velocity times t2. We compare this both of journey, then we get the 420 divided by 900 equal to, we throw the v because the v is same, time 1 is 7 hours divided by time in second process, then we get t2 is 42 t times t2 equal to 90 times 7. So we will get this, we will get 7 and 42, we get 6 times t2 equal to 90. We get that t is 15 hour. Okay, this is another method. Okay, now next, number 5. A car accelerates from rest. If the car acceleration is 20 meters per second square, determine the speed of the car after 5 seconds. From the rest, it means initial velocity equal to 0. Okay. To calculate the final velocity, we use the formula final velocity equal to initial velocity plus minus acceleration times t. Plus minus depends on types of motion. Is it accelerated or decelerated? Is it the velocity become increase or become decrease? If the final velocity become increase, we use the plus sign. But if the final velocity become decrease, we have using minus signs of acceleration. So because this case the car move from rest situation into move motion, so that it means the car is accelerated. So we use the plus sign. Okay, we calculate the final velocity is initial velocity is 0 plus 20 times 5 seconds. So that final velocity is 100 meters per second. Okay, number 6. Armstrong, a French bicycle racing athlete, can pedal his bicycle with initial speed of 10 km per hour in a race. The athlete can achieve finish line within 2 hours with an acceleration of 20 km per hour square. Determine the length of the track the athlete has taken. Okay, we see the known quantity is initial speed. Initial speed is Vi, 10 km per hour. Time is 2 hours. Acceleration is 20 km per hour square. And the question is as the length of track is distance. Okay. Using the known quantity, initial velocity, time and acceleration, for finding the distance, we use this formula. D distance equal to initial velocity times t plus 1/2 a times t square. So that we input the value 10 times 2 plus 1/2 20 times 2 square. 20 plus we got 10 times 4 40 and we get the value is 60 kilometer. Okay. Next, number 7. An object is accelerating at 8 meters per second square. If the initial velocity of the object 6 meters per second, determine the object's velocity after traveling 4 meters. Okay, we know the formula of accelerated motion have 3 formula. We have to remember that 3 formula. First formula is final velocity equal to initial velocity plus minus acceleration times t. Distance equal to initial velocity times t plus 1/2 acceleration times t square. Then final velocity square equal to initial velocity square plus minus 2 times acceleration times displacement. Okay, using the known value from the problem, A acceleration, initial velocity vi, and the question is final velocity, known displacement is 4 meters. We can use the third formula, that final velocity square equal to initial velocity square plus 2 times acceleration times distance. We input the value. Initial velocity is 6 square plus 2 times acceleration is 8. Displacement is 4. Then we got the final velocity square 36 plus 64. This summary will get the 100. So final velocity can be found with the root of 100. So final velocity, we got the 10 value meter per second. Okay, next, number 8. An object was dropped from a building that has a height of 45 meters. We assume the gravity acceleration is 10 meters per second square. Specify the time taken by the object until it reaches the ground, and B, speed when it hits the ground. Okay, we draw the situation. So if this object fall to the ground, so that the object will travel distance about 45 kilometers. This motion is called free fall motion. In free fall motion, the initial velocity is 0. Okay, so that we can use the formula H equal to 1/2 accelerations times t square. Acceleration is gravity, 10 meter per second square, okay, times t square. The height is 45. Then we get the 90 equal to 10 t square. So that we get the 9 equal to t square. So that we get the t is the root of 9. We get the 3 seconds. Okay, next B. The speed. The speed can be found with the formula final velocity equal to g times t. Gravity acceleration is 10 times t is 3. (30 meter per second). Okay. Next, number 9. An object is thrown vertically upwards with an initial velocity of 10 meter per second. Determine the time to reach the maximum height and B, the maximum height. Okay. In upward vertical motion, the object must have initial velocity in order to move upwards. This is the initial velocity. Okay. In uniform accelerated motion, we have the formula to calculate the speed is final velocity equal to initial velocity plus minus gravity times t. Okay, the acceleration change symbol to g, gravity acceleration, because the motion is upwards, then the motion is in opposite direction with gravity acceleration, so that the motion is decelerated. It means the velocity become decreased, so that the formula is final velocity equal to initial velocity minus gt. Okay. If we see the object from initial condition, if it thrown to the top and reach the peak point or maximum point, the velocity from initial point to peak point will be decreased and will have value 0 at the maximum point. So it means the final point of peak point is 0. So that we input the 0 value equal to initial velocity 10 minus 10 times t. Then we get the 10 times t equal to 0. T is 1 second. The maximum height can be found with using the formula height final velocity square equal to initial velocity square minus 2 times gravity times height. 0 equal to 10 square minus 2 times 10 times height. We get the 20h equal to 100, and we get the height is 5 meter. Okay, next, number 10. Look figure below. When and where these two objects will meet. The object A move to the right side, and the object B move to the left side. The velocity of object A is 3 meters per second. The object B velocity is 2 meters per second. Okay, we look the condition. For these two objects will meet, the condition is the distance traveled by them have to be the separation distance 25 meters. So we write the situation condition is distance traveled by A plus distance traveled by B is 25 meters. Yeah. We assume the point of meeting is this point, so that if this distance of A and this is distance of B, if these two value dA plus dB must be 25. Distance A is velocity of A times t plus velocity of B times t equal to 25. Velocity of A is 3 times t plus velocity of B is 2 times t equal to 25. We get the 5 times t equal to 25, and t is 5 seconds. Okay, next question is where these two objects will meet. Okay, we calculate distance A traveled by A is velocity A times t, 3 meters per second times 5 seconds. We get the 15 meters. This is measured from A. But if the meeting point measured from B, it will have the different value. We calculate distance B is Vb times t. Velocity B is 2 times 5, and we get the 10 meters from B. Okay. Next question, number 11. From figure below, when and where these two objects will meet. The object A move to the right side. The object B also move to the right side. The object A has velocity 6 meters per second. The object B has velocity 2 meters per second. The two objects is separated by distance 24 meters. Okay, we assume they will meet in this point, so that if the distance traveled by A is symbolized by dA, and distance traveled by B is symbolized by dB, then the conditions of meeting must be dA equal to 24 plus dB. Okay, the distance A can be calculated from velocity times t equal to 24 plus velocity b times t. Velocity A is 6 times t equal to 24 plus 2t, 2 times t, and we get the 6 times t minus 2 times t equal to 24. 4 times t equal to 24, and we get the t is 24 divided by 4, and we get the 6 seconds. Okay. Next question, where these two objects will meet. We calculate the distance A, VA times t. VA is 6, time is 6, so that we get the 36 meters from A. Okay. Next question, number 12. Object A will meet object B when object A moves how many seconds? Okay, when we look the graphic below, we know that the graphic of line A become more higher, so that it means the object A move with type motion is accelerated increase. But if we see the object B, the straight line, its line remains constant in value 40 meters per second, so that the object B move in uniform linear motion. Okay, these two objects will meet if the condition is their distance meeting point is same, so that we write the distance A is equal to B. So we write the type of motion A is accelerated, and B is uniform. Okay, uniform constant. Because the A move at accelerated motion, so that the formula of distance is initial velocity from A times t plus 1/2 A times square equal to distance of B is move at constant velocity, so the distance can be found by formula velocity of B times t. Okay. Now we see the movement of A. The initial velocity of A is 0, so that we input the 0 times t plus 1/2, or we have known the value of acceleration yet. We calculate the acceleration value of A. Acceleration of object A is change of velocity divided by time. We can see the object A, its velocity change from 0 to 40 in 5 seconds. So that 40 minus 0 divided by 5. So we get the value 8 meter per second square. So we input the value of 8 in acceleration times t square equal to Vb is 40 because it remains constant, the object B motion, times t. So that we get the value of 4 times t square equal to 40 times t. This we move to left side. 4 times t square minus 40 times t equal to 0. Okay, we factorize this equation. 4 times t. Okay, in front become t minus 10. So that we get the two value of this. T is equal to 0 and t minus 10 equal to 0, and we get the t is 0 second. So the two objects will meet each other after they move after 10 seconds. Okay, our lesson until here. Thank you for watching the video. See you again in other video. Goodbye.